On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, once again, we're going to throw the lines open because it's open mic. That's right. Open mic on Science Fantastic. If you want to get on national radio to ask that question that you've always been wanting to ask but never had the chance, then here's what you do. You go to the telephone and you call 612-564-8135. Write that number down, 612-564-8135. You'll get a recording. Be sure to leave your name, call letters to the radio station you're listening to, if you're listening to one, and the city you're calling from, and then ask that question. Make that comment that you've always wanted to ask but never had the opportunity. Let's say it's 4 o'clock in the morning and you're listening to the radio, watching late TV, and something happens in the news, but you have no one to talk to. It's 4 o'clock in the morning. Well, you can talk to me. You can call 612-564-8135. 24 hours, day and night. That hotline number is available. And again, leave your name, call letters to the radio station you're listening to, and the city you're calling from, and then ask that question. And just remember that no question is too dumb or too silly to put on national radio. Chances are, if you have that silly question, chances are hundreds of other people have that exact same question. And sometimes children's questions are the deepest and most profound of all. Years ago, there was a 16-year-old boy who asked himself a stupid question. What happens if you try to outrace a light beam? Such a silly question. But he spent 10 years trying to figure the answer out. What happens if you can outrace a light beam? And 10 years later, he finally figured it out, and he changed world history. His name was Albert Einstein. The theory was relativity, which makes possible the atomic bomb, unleashes the secret of the stars, unleashes the secret of matter and energy. And his theories are right there in your living room. The wonders of modern technology, transistors, and all the different kinds of internet devices that you have, all of it, in some sense, can be traced back to the thinking of a 16-year-old boy who asked himself a stupid question: what happens if you try to outrace a light beam? By the way, the answer is you cannot outrace a light beam. The speed of light is, believe it or not, the ultimate velocity in the universe. And some of you are too bashful to leave your questions on my answering machine. So instead, you can email me. Go to my website, mkaku.org, mkaku.org, and you can leave a question, and we'll try to answer some of those as well. So once again, in this hour, it's open mic on Science Fantastic. Okay, well, let's move on now to the first listener phone call.
Hi, Dr. Kaku. My name is Lance. I'm calling from Green Bay, Wisconsin, and I listen to you through your website. I was just wondering, what would happen if two big bangs were to collide against each other? I want to eventually write a science fiction book just for fun, and as that would be something I'm curious about. So, wonder what you were thinking about two big bangs colliding each other, what happens in the middle? Thank you.
Well, you ask a question that, by golly, we physicists are also asking. The theory is called inflation, which actually fits all the data. It is the leading theory of creation. And my colleague Alan Guth of MIT, who I've actually had on radio, may eventually win the Nobel Prize in physics for inflation. Inflation says that the universe was born in a tremendously cataclysmic event, much bigger than previously thought, but it was a quantum event. In other words, words, there's a certain probability that could happen again and again and again. In other words, big bangs could be happening all the time somewhere out in the universe. So if our universe is a bubble of some sort and the bubble is expanding, that's a picture given to us by Albert Einstein. They were like insects living on the skin of a gigantic bubble that's expanding. But we now believe that the bubble can bud a baby bubble, or baby bubbles can collide to give you a bigger bubble, and that could give you a mini Big Bang. In other words, the leading theory is the theory of the multiverse, that we coexist with other universes. These other universes can collide with us, creating an even bigger Big Bang, or they can peel off and create a baby universe. This is called the multiverse theory, and it's taken the field by storm because it is a quantum theory. You see, Einstein's theory is not a quantum theory. In fact, Einstein himself had reservations about the quantum theory. So Einstein basically thought that the Big Bang happened once and only once, end of story. But you see, in the quantum theory, there's a probability that you can exist in different states. So if the universe popped into existence one time, why not a second time or a third time? Or why can't they even collide? And so, believe it or not, we physicists are actually looking at the possibility of colliding universes. I was at a talk a few years ago given to us by another theoretical physicist, and he asked himself a simple question. Let's say our universe collided with another universe billions of years ago. How would we prove it? What kinds of data would we need to prove the existence of a pre-Big Bang or a pre-collision with another universe? Well, you see, we have, believe it or not, baby pictures of the Big Bang. If you go to nasa.gov and look under COBE or WMAP, you can actually see a picture of the microwave radiation emitted about 300,000 years after the Big Bang. By golly, it looks like an explosion, because it is an explosion. We have photographs of the microwave radiation emitted from the Big Bang itself. Now, here's what we physicists do with this data. We look for irregularities in this picture. It looks like an explosion, and like I said, you can see it on the web. It's an explosion in the microwave range, and we look for irregularities, and by golly, we do find some of them. Now, these irregularities could be remnants of a previous collision that we had, maybe with a smaller universe. So, believe it or not, we physicists are actually looking at slight deformations in the afterglow of creation itself. And we hope to use these aberrations in order to prove that once upon a time we collided with another universe. So yeah, it's science fiction, but this is now fair game for physicists who now believe that once you marry the quantum theory to Einstein's theory of the Big Bang, then all hell breaks loose. Parallel universes, a multiverse of universes, maybe even the laws of physics themselves could be different in other parallel universes. And then people ask me the question, well, if there are other parallel universes out there and we can collide with them, is Elvis Presley still alive in another parallel universe? And one day, could we meet him? Compliments of the multiverse. Well, you can't rule it out. There's a certain finite probability that, that the king is still alive. Okay, well, without further ado, let's go to the next listener phone call.
Hi, my name is Billy. I'm calling from Collinsville, Illinois, and I mostly listen on YouTube. I have a two-part question. Part one, string theory, from what I understand, says hyperspace is at least 10-dimensional, but you theorize it's 11. Why is it that it only needs 10, but you postulate it's 11? Part two of my question is, well, hyperspace states that our four-dimensional universe is a bubble in hyperspace. Our universe is expanding in all directions infinitely and is actually increasing in its expansion, which scientists attribute to dark energy. For someone who believes in string theory, if asked what's on the other side of our universe, the answer I would imagine would simply be hyperspace. That's what we're expanding into. But for someone who believes in another theory, that answer isn't as simple. I would say right on the other side of our universe would be our temporal dimension. If our temporal dimension could permeate through and past our three special spatial dimensions, could it be that our time dimension is dark energy? That is to say, could our time dimension, since its original expansion, be pulling our universe outward? Which would mean that maybe hyperspace doesn't have or need a temporal dimension, and that our temporal dimensions will one day reach the vastest corners of hyperspace. And finally, would that mean that things that exist only in hyperspace exist outside of time? Thank you very much.
Well, the answer to your question is yes. Next question. No, let me try to make a stab at some of your questions, which really go to the very cutting edge of science itself. First of all, many people have seen that Oscar-winning movie, The Theory of Everything, talking about the life of the late cosmologist Stephen Hawking. The movie, The Theory of Everything, won the Oscar. But ironically enough, you can watch the entire movie and they never tell you. They never tell you the name of the theory of everything. And the name of that theory is string theory. We think that's a theory that eluded Einstein for the last 30 years of his life, from 1925 to 1955. He worked on a theory which would unify all the laws of nature into a single framework. And unfortunately, he died before he could complete that process. Well, today, of course, I can read that book. I can read Einstein's book. I can see all the different trails that he went into that were eventually dead ends. One promising trail was to go into hyperspace. Einstein talked about the fourth dimension, 3 dimensions of space, 1 dimension of time, and the possibility of a 5th dimension, but he didn't go far enough. We think that in 10 dimensions, something magical happens. That in 10 dimensions, not only do you have particles like electrons, which are dots, but also you have strings emerging, and these strings can vibrate, and each vibration corresponds to a subatomic particle, and that's why we have so many subatomic particles. They're nothing but musical notes on a tiny, eensy-weensy little violin string. So think of a rubber band. A rubber band from a distance looks like a point, but close up you see that it's a rubber band that can vibrate in different modes. Each mode is a subatomic particle. So if I could photograph an electron, magnify the photograph, I would see that it's not a dot at all. That the electron, which is in your cell phone, is actually a vibrating rubber band. But if it vibrates at different frequencies, it becomes a different particle. So physics is reduced to the harmonies of 10-dimensional strings. And chemistry is nothing but the melodies you can play on these strings. And the universe is a symphony of strings. And what is the mind of God that Albert Einstein spent 30 years of his life chasing after? The mind of God is cosmic music resonating through 10-dimensional hyperspace. Now, the listener asked a question. What about the 11th dimension? Well, you see, there are some problems. First of all, in 10 dimensions, you can summarize all of string theory into an equation 1 inch long. In fact, that's my equation. Google string field theory, and that's one of the things that I created, which allows you to summarize all of string theory into an equation about 1 inch long. So, what's the problem? There's always a problem someplace, right? It turns out that in 10 dimensions, there are not 1, but 5 different self-consistent string theories. Now, we physicists tried to ignore this problem for many years, but it kind of like was always gnawing at us that there are not 1, but 5 different string theories in 10 dimensions. And then the people at Princeton discovered that if you add 1 extra dimension, you go to 11 dimensions, then these 5 strings coalesce into 1 membrane. And this shook up the whole field of string theory. We now began to realize that maybe strings themselves are not fundamental, that there's a membrane living in a higher dimension, the 11th dimension, which can give us another theory called M theory. Now, it turns out that, well, it could be right. I think so. That why would God create a universe with 5 separate string theories, each of which is capable of describing our world? Why not one theory in 11 dimensions? And that's what many physicists are working on now, M theory. Now, is there a similar equation to the one that I wrote years ago, summarizing all of the theory into an equation 1 inch long? And the answer is no. If you want to become famous, then try to summarize the 5 different string theories into a single equation in 11 dimension. It turns out that some of the brightest minds of the universe, the brightest minds on Earth, have tried to do that and have failed. In fact, that's what I'm working on now, trying to unify the 5 different string theories into one membrane in 11 dimensions. And then the questioner asks yet another question about dark energy and temporal dimensions. So let me try to explain. Our universe is 4-dimensional. That is, it has 3 dimensions of time. 3 dimensions of space, and 1 dimension of time. But even Einstein believed that it was nothing but a bubble of some sort. But what is the bubble expanding into? Even children ask that question. If the universe is expanding, what is it expanding into? Well, we think it's expanding into a greater arena of hyperspace, 10, possibly 11-dimensional hyperspace. So in other words, it was Shakespeare himself who said that the universe is a stage, and we're actors and actresses making our entrances and exits on the stage of the universe. Well, that was the picture adopted by Isaac Newton. Then along comes Einstein, who says, not so fast, not so fast. That stage is warped. That stage is curved. And that gives you the illusion of a mysterious force pervading the universe, because the universe is more than just a stage, it's a warped stage. Well, now we believe that that stage of life is nothing but a ball of some sort, a bubble floating in a much bigger stage, 11-dimensional hyperspace. So now imagine a stage with soap bubbles on it. Lots of soap bubbles popping into existence, popping out of existence. That's the new theory, the theory coming from string theory of hyperspace. And dark energy is the energy pushing the galaxies apart. So when children ask the question, why is the universe expanding? We think that it's dark energy, the energy of the vacuum, the energy of an empty bubble that is pushing the galaxies apart, creating the Big Bang. That's why the universe is expanding, because of dark energy. Well, if you want to find out more about this, get a copy of my earlier book, Parallel Worlds and Hyperspace, because they go into much more details about the cutting edge of science itself, which is now trying to unravel the instant of creation. Okay, well, let's move on now to the next listener phone call.
Hi, Michio Kaku. My name is Jonathan. I am living in San Francisco, and I am a SF State student.
Now, before the break, we had a question. I had to cut him off, sorry. A question about, well, is the universe a simulation? Is it nothing but a computer program? Is reality a fake? In other words, sometimes late at night, you turn on the TV and you watch these old movies on TV, and then you ask yourself a simple question. Well, these actors and actresses on the TV screen, do they know that they're nothing but images on electrons on a TV screen? They're not real? Well, you begin to wonder, is reality itself an old movie? That is, did someone hit the play button and a CD-ROM starts to whirl, and we are like those images you see in an old movie on TV at late at night. We act as if we have free will. We act as if, in the movie, as if we can make a decision. But the ending. The ending of the movie is just a movie. And so then the question is that reality? Is reality itself just a movie? And we're dancing on the stage of life, thinking that we have free will, thinking that we can decide the future, when actually we're nothing but celluloid on a celluloid film inside a CD that somebody hit the play button with. Is that possible? Well, computers are getting more powerful all the time, and we can begin to simulate things like airflow on a jet plane. We can begin to simulate the DNA molecule. And so people begin to think, well, I saw the movie The Matrix. And in the movie The Matrix, the robots are so smart, they created a fake reality. And we think we're moving in this fake reality, but no, we're not. We're nothing but people in a pod that's being used as a battery for the aliens. Well, that's the movie The Matrix. But some people think that, well, can you rule it out? Well, I think so. First of all, if you take a look at the weather report only goes for just a few days into the future. Why can't we simulate the weather 100 years into the future? Because the weather consists of billions upon billions and trillions of air molecules. Each air molecule obeys the laws of physics. And the laws of physics, even though you can model an air molecule, there's so many of them. There's so many air molecules that it would exhaust the power of an ordinary computer to model the weather. In other words, the smallest object that can model the weather realistically, that can predict the weather 100 years into the future, is the weather itself. So when we say that the smallest object that can model something is the model itself, it means basically you can't do it. You cannot simulate it. It's simply too complicated. And that's the weather. That's why the weathermen and the weatherwomen only go just a few days into the future. After that, all your computer projections are nonsense. Some people say that they're walking down the street, just minding their own business, and they see the mountains, they see the clouds, they see rivers, and then they wonder, where did it come from? How old are they? Why do we have the shape of the mountains as they are? What shapes the clouds? And then you see the night sky, and you see the moon. You see the stars, and then you begin to wonder, where did it all come from? What does it all mean? Well, these are the questions that you can ask on Science Fantastic. Give us a call. The hotline number is 612-564-8135. And some people feel like they're nothing but a leaf blown in the wind, that they have no control over their destiny because they don't know where they fit into the larger scheme of things. Well, find out. I'm a scientist. I can tell you why the mountains are shaped the way they are, how the clouds form, why the stars twinkle. This is all a matter of science. So give us a call at 612-564-8135. Well, what I'd like to do now is answer some of the email questions that I get. And because, well, to be frank, some people are a little bit shy about asking their question on national radio. So some people prefer to simply email me. So let me answer some of the questions that I get. One set of questions I get is about the Space Force. Back in 1947, that was the last time that a president of the United States, President Truman, authorized the creation of a new branch of the armed forces. Back then, it was the Air Force. And there was a certain amount of bureaucratic resistance to it because the Navy had planes, the Army had planes, and here was a new branch. It was sort of like taking an arm or a leg out of the Navy and an Army and creating a new branch called the Air Force. Well, now President Donald Trump wants to create a Space Force. And again, we have a certain amount of resistance from the Air Force this time because it's like pulling an arm, pulling a leg out of the Air Force to create the Space Force. But let's take a look at the science now, not the bureaucracy, but the science behind the Space Force and what's really happening. First of all, we can't be naive, and that is the Russians and the Chinese. Yes, they're also experimenting with space weapons. In fact, the Chinese, about 10 years ago, even blew one of their satellites right out of the sky, creating a tremendous amount of debris and pollution in outer space. And of course, the Russians can do it. We can do it too. In fact, the Russians even announced that they're experimenting with laser weapons that can conceivably knock out a satellite with laser beams. So let's not be naive about it. Other people are working on it too. So why not be the cop on the block? That's the pro side. The pro argument is, why not give a certain amount of order to the whole space race? We're going to have more and more spacefaring civilizations in space, so why not be the cop on the block? However, there's the reality of what a war may look like in outer space. First of all, the Russians have said that if we go for a space force, they too will begin a militarization of their force. And what would a war in outer space look like? Well, it wouldn't be very pretty. First of all, even a small nation, a nation like North Korea, could, in principle, detonate an atomic bomb over Kansas, creating an electromagnetic pulse, a shock wave, which would knock out half our satellites, blinding us, and knocking out most of our power plants on the planet Earth. Now, that would set us back 100 years. Think about it. The military would be paralyzed. We wouldn't have any eyes or ears in outer space anymore. Power plants would go down, creating blackouts over all of North America. Within a few days, we would have food riots because all the refrigerators would go on the blink, and there's no one to fix it because they too, in the nearest city, they too had their power knocked out. So in other words, a war in outer space is not going to be a pretty thing. And any country that wants to fight a war in outer space has to be prepared for a worst-case scenario, which is the electromagnetic pulse set off from an atomic bomb in outer space. Give us a call. Well, once again, it's open mic on Science Fantastic, and now we're reading some email questions that I get because, well, to be frank, some people are a little bit bashful about having their voice heard on national radio. Well, another question I get is about the heat wave. Look, it's summertime now, the dog days of summer when many people head on to the beach. But some people are noticing, well, this summer seems to be hotter than normal. And in the Middle East, the desert has never been as hot. World records are being set. And some climatologists are saying that if you peek into the future, of course, decades into the future, certain areas of the Middle East may be unlivable. And some people say, aha, it's global warming. Other people say, not so fast, not so fast. Well, first of all, I'm a scientist, and we realize that you cannot say with 100% certainty about anything because you have to test it. You have to run experiment after experiment. And with 90% confidence, not 100%, but with 90% confidence, a majority of the world's scientists believe that the Earth is heating up and humans have something to do with it. Now, even the skeptics of global warming admit that the Earth is heating up. We know that for sure. We can measure the temperature of the Earth from outer space. We can see that the glaciers are receding, that cracks are forming in the South Pole, and the average temperature is rising as sea levels rise. So this is something that we all agree upon. The disagreement comes from the question of human intervention. How much of it is a natural cycle? How much of it is human? And when you look at human behavior versus natural cycles, you realize that most natural cycles take thousands of years. Thousands of years. The last ice age ended 10,000 years ago, and we may have another ice age 10,000 years from now. But it turns out that we're in the middle of an interglacial period. But the temperatures just within the last 100 years have been rising dramatically, especially the carbon dioxide level. And that's why you can say, not with 100% confidence, but with 90% confidence, that humans may have something to do with the fact that the Earth is heating up. Now, does that mean that the heat wave that is hitting the Middle East, the heat wave hitting California, creating forest fires, is that caused by global warming? Well, again, global warming is an average effect. There is no one-to-one relationship. And anyone who claims that, aha, this is the fingerprint of global warming doesn't know what they're talking about. Global warming is an average effect. Over a period of time, you can see that on average, temperatures will rise. On average, sea levels will rise. On average, glaciers will begin to recede. But you cannot say that any one particular hurricane, you cannot say that one particular storm is due to global warming. But like I said, with 90% confidence, most climatologists with the computer programs can say that on average, the Earth is heating up, and we see that everywhere we look on the planet Earth. Well, we have another story, and this is about Alzheimer's disease. Alzheimer's disease, some people think, could be the story of the century. Baby boomers are getting older. And by the time you're in your 80s, a good fraction of the population naturally comes down with Alzheimer's disease, even if you've been healthy all your life, even if you have no genetic markers, and even if you seem to be totally fit, you too can come down with Alzheimer's, because a certain fraction, bordering on about half of people in their 80s to late 80s naturally come down with Alzheimer's. So why don't we cure it? Well, first of all, we don't know what causes it, but a breakthrough was made just last week in order to understand the origin of Alzheimer's. First of all, if you do a test on Alzheimer's patients, you find a gum that gums up the brain, but scientists didn't know whether it was a cause or an effect of Alzheimer's disease. Well, beta amyloid protein is the gum that gums up the brain of people with Alzheimer's disease, but sometimes people have gum in their brain, but they're still very clear in their thinking. So it's not a one-to-one phenomenon. Now we know that the tau protein originates first and then creates the beta protein. But then the question is, where does the tau protein come from? And that was a minor breakthrough made just a few weeks ago. The scientists were able to show the molecular origin of the tau protein, which goes berserk, creating the beta amyloid, which then gums up the human brain. Now, does that mean that we can reverse Alzheimer's? No, but it means that in animals, scientists have been able to isolate that point where the tau protein goes haywire, and they've been able to slow down the progression of Alzheimer's in animals. Now they're trying it on humans. So it does not mean a cure anytime soon, but it does mean that we're onto something. For the first time, we have a solid lead that, yes, we can now see the biochemical mechanism by which the tau protein goes haywire, stimulates the beta proteins to create the amyloids, which then gum up the human brain, giving you what is called Alzheimer's disease. That is not a cure. Talking about going back to the moon. Starting next year, an unmanned probe will be sent back to the moon. Then 3 years after that, we're going back to the moon with astronauts. Then on to Mars and beyond, perhaps to the asteroid belt, and maybe one day to the stars. Find out about what all the excitement is about by getting a copy of my latest book, The Future of Humanity, talking about the future of the space program. Okay, well, let's get right to the listener phone calls. So let's have the first call.
Hi, this is Tom Myers from Rochester, New York. I saw this on a tweet. What will it take to get the U.S. to use the metric system, period? Our students are being forced to learn two systems. Their main system, it gives them a handicap when they're using science. This is not a good thing. Thank you.
Yes, I sympathize with you wholeheartedly. When I go traveling around the world, I realize that everybody uses the metric system. Everybody talks in terms of meters and centimeters, except when they come back to the United States. It's back to the old U.S. system. Now, at one point, there was a national campaign years ago to convert to the metric system. However, it never materialized because of, force of habit. It costs money to make the change. And it also is a question of inertia, bureaucratic inertia. You see, politicians don't get points. They don't get reelected by being the champion of the metric system, and people are naturally conservative. Now, in other countries, they have to convert, because if you want to engage in commerce, international commerce, then you have to go to the metric system. However, the United States is the 800-pound gorilla. As a consequence, we wanted them to conform to us. Let them convert metric system and our system. Now, it turns out this has practical implications. Years ago, we sent a Mars probe into outer space, and there was a miscalibration because of the conversion from the English system to the metric system, and our space probe was lost as a consequence. So in other words, this has million-dollar consequences. It's not just a question of inconvenience. It's also a question of mistakes are made as a consequence. But politicians have to get behind it, and unfortunately, there's no brownie points that politicians get by pushing something that's unpopular in this country like the metric system. I sympathize with you, but ultimately, it's up to the politicians. Sorry about that. Okay, let's move on to the next listener phone call.
Stephen Winter calling from Clinton, Mississippi. Radio station's 103.9 WYAB. My question is concerning global warming. If I'm not mistaken, when I was in high school in the 70s, they were talking about us coming out of a mini ice age or something like that. They were expecting it to get warmer back then. I just wondered what's happened between then and now. Was that information off track, or we got folks wanting to blame everything on CO2 emissions, which I believe one volcano produces a huge amount. Anyway, that's my question. Just curious about that. Thank you.
Okay, well, you ask a question that's very relevant for today. First of all, there are two kinds of atmospheric disturbances. One is long-term and one is short-term. Now, ice ages come and go on a scale of tens of thousands of years. The last ice age ended 10,000 years ago, and that made possible the rise of civilization. Civilizations could not exist when most of North America was covered with a half a mile of ice. And so we were basically nomads going from one small hunting site to another, chasing after the deer and the buffalo, who also migrated. And it was a very hard life. Then 10,000 years ago, the ice melted, making possible civilization. But these are long-term cycles. In another 10,000 years, we will have another ice age. In other words, 10,000 years from now, don't be surprised if America is under a half a mile of ice. Now, the other question is about global warming. Now we're talking about things that change the weather, not on a scale of tens of thousands of years, forecasting another ice age in 10,000 years, but cycles which happen on a scale of decades to centuries, which are usually not natural. Natural cycles usually take thousands to hundreds of thousands of years, but here we're talking about a change that's taking place on a scale of decades. When you look at the last 100 years, for example, you realize that since the Industrial Revolution, temperatures have risen about a degree, that also sea levels have risen at a very measurable rate, caused by the warming of the oceans. Now, the Earth is warming up. You can talk to any farmer. Any farmer will tell you that his or her livelihood depends on knowing when to plant and what the seasons are. And yes, summertime is about a week longer than before. So global warming, just in the sense of warming, is here. Even President George W. Bush years ago said, quote, something is happening, unquote, with the weather that even the average person knows. Now, here's where the debate comes in. The debate comes in as to how much human activity is responsible for global warming. So in other words, even the so-called skeptics will concede now the fact that the Earth is warming up. Well, before the break, we had a question about global warming. Yes, even the skeptics will say that the Earth is warming. And years ago, I was a skeptic myself. I used to say to myself, come on, now give me a break. The Earth is so big, it's huge. And humans, we're so tiny. How can we humans influence something as big as the weather? But then you take a look at what's happening with the Earth itself. all the indicators show that the Earth is warming and it's accelerating. We see that all the major glaciers are receding. All the major glaciers are receding on the planet Earth. Parts of Antarctica are beginning to break off. The stability of Antarctica is now being questioned. We see the fact that summer times are about a week longer than normal. And we see that global swings of the weather are commonplace now. 100-year floods, 100-year forest fires, 100-year this, 100-year that. They seem to be happening all the time. And then the big question is, how much of it is due to human activity? Well, scientists use computer programs. Some people don't like them, but what else are you going to do? Use pencil and paper? When you use computer programs to run the videotape, what you find is that with 90% confidence, it is human activity. Now, 90% confidence is not 100%. Scientists are not saying that with 100% accuracy we say that it's human activity, but with 90% confidence they say it's human activity that is causing the Earth to heat up. Okay, well, let's move on now to the next listener phone call.
Hi, Dr. Kaku. This is Ben in Chicago. Are atomic events recorded in space-time similar to the way in which digital data is recorded on storage media? And if so, would it be theoretically possible to read historical events of the past and then recreate them in the present? In other words, you'd be time traveling to the past, not to alter the past, but to gather data of past events and then recreate them in the present, so you could perhaps alter past events in the present. Doing this would avoid any time traveling paradoxes, and it could be a way to resurrect a dead person by recreating their bodies and memories in the present time in a way that wasn't possible in the past. Thanks.
Well, you actually ask a question that I used to ask myself as a youth a long time ago. Let's say there's a crime. The light emitted from the crime has bounced off the walls, but if you could reassemble all the light, then you could in principle recreate the scene of the crime. So I thought to myself, wow, I mean, we have all this knowledge about atomic physics. We have all this knowledge about atoms and photons and electrons. Why can't we collect all this data, not digital data, but atomic data, and then run the videotape backwards to reconstruct the crime? Well, great idea, but in practice, it's not practical for several reasons. First of all, when light scatters off a substance, let's say there is a crime and light from the crime hits the walls, light scatters in all these different directions, and to recreate that wavefront would require you to know everything there is about the original wave, everything about the texture of the wall that bounced the light off, and the amount of data would be incredible. And so it's not possible using ordinary techniques to then recreate the wavefront. Sorry about that. However, some people have suggested that even though we can't duplicate the atomic data, the digital data may somehow be reconstructed to create an approximation of reality. This is called digital immortality. One Silicon Valley company is already offering to digitize everything known about you. Your credit card records, your Instagram pictures, everything known about you on the web can be digitized to get you a first approximation to who you are. Now, as time goes by, more and more information will be collected about you to the point that we may be able to reconstruct a reasonable facsimile of who you are. And the Silicon Valley company actually is offering to create a robot that looks like you, talks like you, has the same mannerisms as you. I've actually seen the robot, and it's not very advanced, so don't get your hopes up. But the question of digital immortality is a possibility. For example, take a look at Winston Churchill. Let's say you digitize everything known about Winston Churchill. So when you go to the library, you talk to him. You talk to a holographic image that reproduces the sound, inflection, historical notes, everything known about Winston Winston Churchill. I mean, I wouldn't mind talking to Einstein. I'd have a great time talking to Einstein, or even a reasonable facsimile of Einstein. And then, maybe decades from now, the Connectome project will be finished. The Connectome project will map the entire brain. Every neuron of the brain can be mapped to recreate a facsimile of your thinking brain, including your memories, your personality. We're talking about a digital version of you that is immortal. Now, is it really immortal? Well, to paraphrase former President Bill Clinton, it all depends on how you define you. If you are a biological being, then no, this is nothing but a digital tape recorder. However, if you is the sum total of all the information that is known about you, your mannerisms, your feelings, your memories, everything known about you, if that is you, then in some sense we have digitized your soul. So your soul is now being reduced to information. Now, is this possible? Certainly possible. Is it economical and practical? That I don't know. But as computer prices continue to drop, some people may want the option of not biological immortality, but digital immortality. Okay, let's move on to the next listener phone call.
Barton Salin, listening on WSRQ in Sarasota, Florida. Since general relativity says that a clock on the sun would run slower than a clock on the Earth because of the greater gravitational force on the sun, if a clock could survive on the sun, doesn't that mean that those time differences between the sun's clock and our clock would accumulate, so that when we look at the sun today, we would not be seeing it as it is today, but rather as it was in the time of the dinosaurs? Now, I realize that today we see the sun as it is today because when there is a flare on the sun, if it's in the right position, we get hit a few hours later by particles from that flare. So we know that we're watching the sun as it is today. Thank you.
Yes, well, you ask a very interesting question. It turns out that the speed of gravity is the speed of light. If the sun were to disappear right now, it would take 8 minutes. 8 minutes for that information to hit the Earth. So even gravity has a finite speed. Now, as you pointed out, time beats at different rates throughout the universe. On the moon, time beats faster. So if I have a clock on the moon and a clock on the Earth, and the two clocks can talk to each other, the clock on the moon beats faster than a clock on the planet Earth. And this is actually measurable. So this is not science fiction. This is science fact. Get used to it. In fact, Einstein once said that he put a clock at every point in the entire universe. You put a clock, all of them beating at a different rate, but he was so poor he couldn't afford a clock of his own. But it's true. Time beats at different rates throughout the universe. So you're saying, can you accumulate this difference in time? The answer is yes, but it is infinitesimal. So if I have an astronaut on the moon and an astronaut on the Earth, a twin, and they eventually meet years later, they will only be a fraction of a second delayed between the two twins. Okay, let's move on now to the next listener phone call.
Hey, this is Armand from Queens, New York. I listen to you on YouTube. I was wondering, why do you think Elon Musk thinks that we live in like a simulation? Like, we're a simulation pretty much. We're, made by computers or whatever. I know you believe in the multiverse theory. Well, why do you think Elon Musk believes that we're like a simulation or like a program? Thank you. I love your show. Have a great one.
Excellent question. Well, as I mentioned in my book, The Future of Humanity, we have Silicon Valley billionaires affecting the direction of the space program. And so these people made their money on the internet. For example, Elon Musk was a PhD candidate in physics, like Wernher von Braun, the famous rocket scientist. Elon Musk also went into the PhD program in physics, but after just 2 weeks at Stanford University, he decided, nope, this is not for me. The money is in Silicon Valley. So people in Silicon Valley think you can digitize everything. But you see, there are limits to what you can digitize. For example, how many atoms are there in your body? I mean, there are 10 to the 23 atoms in a mole. Your body consists of many, many moles. And so the number of atoms in your body could be on the order of 10 to the 26 atoms. That's an enormous number of atoms that you cannot digitize. Take a look at the weather. The smallest object that can simulate the weather is not a supercomputer. Even a supercomputer cannot model the weather and every atom of the weather accurately. The smallest object that can model and reproduce the weather is the weather itself. So we say that these things are not calculable. There are simply so many ways in which atoms can vibrate inside a gas to create the weather that is simply not practical to build a machine that can duplicate every single atom bouncing around inside the atmosphere. Now, people and reality is much more complicated than the weather. And so that's why even classical physics, Newtonian physics, cannot be modeled using a computer. It cannot be digitized. Now, quantum mechanics makes it worse. Quantum mechanics says that all possible universes are possible. And so you would have to digitize not just one universe, you would have to digitize all possible universes in the world of quantum mechanics. Okay, let's move on now to the next listener phone call.
Hello, sir. My name is Gail Phillips. I'm actually not listening to a radio station. I'm looking you up online, and I'm calling from Bahrain, in the Middle East. My question is, I sort of have a two-part question. How close are we to making colonies on other planets, or even the moon, or making colonies elsewhere other than Earth, is what I'm trying to say. Exactly how close we are to doing that. And also, one of my favorite episodes of yours is the episode of Sci-Fi Science where you make the lightsaber. How close are we to making the lightsaber from the time you made that episode to now? So I apologize for the two-part question, but that is my two most favorite interests. Thank you very much. My name is Gail Phillips from Bahrain, and hope to hear from you soon. Thank you.
Well, what a phone call. Yes, I've been to the Middle East, and yes, I'll try to answer your questions. First of all, the colonization of planets is still going to be decades away. Just last December, President Donald Trump issued the Space Policy Directive number 1. And that Space Policy Directive reversed the policies of Barack Obama. Barack Obama basically ended the U.S. manned space program. He canceled the space shuttle, canceled the replacement for the space shuttle, canceled the moon program, and then also canceled the Mars program. However, Space Directive number 1 says we are going back to the moon, then to Mars, and then beyond, perhaps the asteroid belt. Now, let's be real about this. The timetable, of course, is still speculative. Starting December of 2019, the end of next year, NASA intends to send the SLS booster rocket into outer space, and the capsule will go around the moon, unmanned capsule. Then, around 3 years after that, astronauts will go back to the moon. And then around 2030 to 2035, that's when the first astronauts will go to Mars. And then once we're on Mars, we have to set up a Mars colony. And that'll, of course, take even more time. Perhaps we'll use a lava tube as a makeshift base of operations to protect us against cosmic rays and the harsh atmospheric conditions of Mars. Then we'll create a power plant by putting out solar panels, and then begin mining operations. Why that? Because ice is a valuable commodity. Mars has plenty of ice. It's a frozen desert. Ice can be melted and purified to give drinking water, broken apart into oxygen and hydrogen to create rocket fuel for the return mission. So again, first we go to Mars, put our flag on Mars, set up a impromptu base of operations, but then we're talking about long-term operations, basically starting mining to extract water. After that, we're going to set up a agribusiness. In other words, we're going to use genetic engineering to create varieties of algae and crops that can be sustained in the harsh conditions of Mars. The goal is to make it self-sustaining, so it's not going to cost anything at all. For example, it turns out that Mars rock can be melted using microwave radiation. This has actually been done in the laboratory to create duplicate rock of Mars, hit it with ultraviolet radiation, and melt it to create brick. So in other words, it's possible to use the soil of Mars to create brick, which will be used as building materials. It'll be possible to mine the ice. The break, we had a two-part question, and that is, what would it take for us to build a colony on other planets? And, well, in the 2030s, that's the earliest we could have humans on the red planet. And then it'll take decades after that before we set up the first mining operations. We set up the first agribusiness, and we make it self-sustaining for colonists. And then to create a paradise on Mars, we would have to send solar satellites to then beam solar energy down to the polar ice caps to melt the polar ice caps so that liquid water flows on the surface of Mars once again. And so hopefully, perhaps late in this century, we will have a self-sustaining Martian colony that's not going to cost anything, so that colonists will have a self-sustaining economy based on mining operations, based on agribusiness, to create a permanent settlement on Mars. And then beyond that, well, get a copy of my book, The Future of Humanity, where I talk about going beyond that to Europa, to Titan, and then perhaps even to the nearby planets surrounding other star systems. Now, the other part to the question that we had earlier was the lightsaber. Well, for the Science Channel, I once hosted a science series where we went through the hardware of science fiction, looking at them from the point of view of a physicist. So we looked at the lightsaber. Now, first of all, the lightsaber has a problem, and that is it extends a finite distance from the hilt. Now, how do you do that? Light, of course, simply keeps on going forever unless it bounces off something. So one way in which you can create the temperatures of a lightsaber is with a plasma torch. Plasma torches are actually commercially available. It's basically a large spark that can create a plasma. Now, a plasma is the fourth state of matter. We have solid, liquid, gases, but the sun is not made of a solid, liquid, or gas. The sun is made out of a plasma. That is a gas of disassociated atoms that have been broken up, and you can create plasma using electricity. So if I have a plasma torch, then I could use that to cut right through steel, for example, and simulate a lightsaber. However, it's not a true lightsaber in the sense that it goes a finite distance. A lightsaber, of course, is based on light, which can in fact go an infinite distance. But this is as close as you can get to a lightsaber using today's technology. So the lightsaber would have to have a spine. It would have to have a spine that then emits the plasma from the spine and then creates the lightsaber. Now, it is not exactly what you find in Star Wars, but it's as close as you can get using today's and tomorrow's technology. Okay, let's move on to the next listener phone call.
Yes, Dr. Kaku, this is Justin from Texas. I listen to KMET. I was just wondering, what do you think the current administration of the United States is going to do about the problems we have with the space station, International Space Station? What do you think? They're talking about, I guess, renting it out. What do you think the best idea would be to use with the International Space Station? Thank you very much.
Well, you ask a very embarrassing question because at the present time, we don't know what to do with the International Space Station. First of all, let me explain what the administration is doing. The Trump administration has issued, at the present time, 3 space directives. Space Policy Directive 1 talked about going back to the moon, then to Mars and beyond. The second directive talked about private enterprise and encouraging the deregulation of outer space. The Space Directive number 3 talked about space junk. So the administration has not yet stated what its policy is toward the space station. Now, it depends on who you talk to. If you talk to a pure scientist, they would say that we get actually very little new science from the space station. So they say that we perhaps don't even need a space station. And today, we're going to be talking about the future of humanity with respect to genetics. The book is called Hacking Darwin, Genetic Engineering and the Future of Humanity. And the author we have with us today is Jamie Metzl. He's a futurist, a geopolitical expert, a science fiction novelist, a senior fellow at the Atlantic Council. He's been at the White House, the State Department, and the United Nations. And his latest book is called Hacking Darwin, Genetic Engineering and the Future of Humanity. And also, you may want to check out my website. Go to mkaku.org, mkaku.org. On Facebook, we have 3 million fans on Facebook. On Twitter, we have about 1 million people that pick up the Twitter feed every week. And you can see the 4 New York Times bestsellers that I've written in the past. The latest one is called The Future of Humanity, talking about the future of the space program. We're headed back to the moon, maybe Mars, maybe one day to the stars. And so we'll talk about the future of humanity in my book, The Future of Humanity, talking about the future of the space program. And then in The Future of the Mind, I talk about how we physicists are now beginning to probe the deepest secrets of the living brain. Telepathy, telekinesis, recording dreams, recording images in the mind. All these things were once considered the stuff of science fiction, but hey, that's what we physicists do. We can actually extract images from the living brain. We can actually telepathically connect minds with other minds. In fact, the late Stephen Hawking, a colleague of mine, if you see tape recordings that he did, you'll realize that in his right glass, we put a chip in his right glass that picked up radio signals from a radio that then was analyzing his thoughts and then projecting it onto a laptop computer. So by thinking, Stephen was able to send radio messages through that chip to a laptop and then communicate with the world. Well, anyway, today we are talking about genetic engineering. And we're going to go to an imaginary hospital. The year is now 2045. Mr. Metzl has written the New York Times op-ed piece where he goes to a fertility clinic in the year 2045, and we're going to talk about the different options you will have. Is it possible, like ordering a car, to order the different characteristics that you want your child to have? Well, think of the good we could do by eliminating genetic diseases. But think of all the mischief we can also do if we can control our own genetic heritage. And so we'll be talking about the science as well as the ethics of hacking Darwin. So Jamie, glad you could be on Science Fantastic.
Thanks so much, Mitchie. I'm absolutely thrilled to be here with you.
Okay, first question for you is when you were a young kid, go back now. When you were a young kid, most kids perhaps want to become astronauts or policemen or whatever, but you got into public policy. So what steered you in that direction?
Yeah, well, it's a great question, and I have kind of a unique and I would say a special history in that my father and grandparents came to this country as refugees after the war, so their lives had been devastated by Nazism. And so I grew up with a very keen appreciation of what can happen when politics goes wrong. And that was really what gave me this passion for human rights and civil rights and governance. And that was my first entry into the world of policy. I worked on the National Security Council. But before that, I had worked in refugee camps in Thailand, working with Cambodian and Hmong and Vietnamese refugees. And that was what also transitioned me into my appreciation that just like governance and policy affects people's lives, science and the values that are realized through science can massively impact people's lives, because we're talking about Darwinian evolution. The Nazis themselves saw themselves as implementers of their interpretation of Darwin.
Now, when we think of public policy, we think of high mucky mucks out there playing a gigantic chess game, China, Russia, the United States, Iran. However, your book is called Hacking Darwin. So what steered you in the direction of looking at the future of genetics?
So more than 20 years ago, I was on the National Security Council, and my boss then and good friend now, Richard Clark, was the person who many years before 9/11 essentially predicted that we would be attacked and said it would be by a group called Al-Qaeda, and said that we needed to go after bin Laden, but nobody would listen. And he was really a Cassandra. And Dick always used to say that if everyone in Washington was focusing on one thing, you could be sure there was something much more important that was being missed. So more than 20 years ago, I started picking up these little pieces and putting them together into this story that our world was going to change in deep and fundamental ways as a result of the genetics and biotechnology revolution. And so I first educated myself, and then I started writing policy articles, and then I was invited to testify before Congress and got more and more involved. And then I realized that in order to communicate the story that I was trying to tell and engage people, I needed to find a different way to communicate. And that was why I wrote the science fiction novels. And then in my book tours for the sci-fi novels, when I explained the science the way a storyteller and the way someone who had taught themselves the self-science would explain it, just like you do, Michio, in your incredible books. I mean, you take these these complex ideas and you translate them so that anybody can read one of your books and say, yeah, I get it. That's also what I have tried to do in Hacking Darwin, to tell the story of the genetics revolution in a fully accessible way, so that people who are reading the book can say, hey, this isn't just abstract science. This is about me and my future and my children and my world. And in order to influence how these technologies develop, I need to be informed.
Okay, well, let's talk about the past, the present, and then the future of genetic engineering. About 15 or so years ago, I did a story about an Orthodox Jewish sect in Brooklyn that was afflicted by Tay-Sachs. Tay-Sachs is a horrible genetic disease afflicting European Jews. And scientists have been able to isolate the genes and the markers for Tay-Sachs. And so in this community, they take fertilized eggs that were fertilized in a test tube, analyze them to see which embryos have the Tay-Sachs, which ones don't, and then discard the ones that have the Tay-Sachs. So in one generation, in principle, you can eliminate this dreaded disease. Now, that was over a decade ago. Let's say you visit a fertility clinic today. What kinds of genetic diseases and enhancements are possible? And then we'll talk about the year 2045. Great.
So if you go to an IVF fertility clinic today, and you have IVF, in vitro fertilization, which that has to be your first step if you want to apply all of this science that we're going to talk about to procreation.
We're talking about, well, a visit to a fertility clinic today, and then leaping forward into the year 2045. So again, continuing discussion. You go to a fertility clinic. What do they offer in terms of genetic engineering today?
Right. So first, you have to use in vitro fertilization. So the woman has her eggs extracted. The eggs are fertilized with the male sperm. They're grown for about 5 days. And then a few cells are extracted from each of these early-stage pre-implanted embryos and sequenced. And so right now, the primary reason that you would do this and what you can screen for are many of what are called single-gene mutation diseases and disorders. So these are things like you mentioned Tay-Sachs, and there's sickle cell disease, Huntington's. There's about 7,000 of these where it's a single letter, a single gene mutation that's off, and that, in many, many cases can cause some terrible genetic diseases. And so there's that. There's chromosomal disorders, things like Down syndrome. And then there's some relatively genetically simple traits like eye color. So that's kind of the suite of options now. But I want to answer. I'll wait for you to ask the next question, but that is about to change in a very big way.
Now, the young couple can then decide which of these embryos they want to put to completion, and they would then disregard all the other ones that have a genetic defect. But what about the possibility one day of curing that defect, rewriting that one letter in your genetic alphabet that is misspelled? Now, is that possible or not?
That's certainly possible. So there's a whole new category of treatments that are called gene therapies, and that is exactly what you've described. And there are two ways to deliver these gene therapies. One is to take cells outside of your body and to edit them, and there's a class of cancer treatments, for example, called CAR T therapies that do exactly that. They take out your cells, in this case, blood cells. They engineer them to enhance their natural cancer-fighting superpowers, and then they put these super cells back in your body. And because they're stem cells, these cells proliferate, and your body becomes much better at fighting off cancer. So that's one, is taking your cells out. The other is delivering these new instructions to your cells by a virus, the safe virus, that is introduced into your body. So that whole category of gene therapy is now in its early stage, but that's going to be a very, very significant part of healthcare going forward. But it's not going to be able to fix everything, and so there'll be some of these disorders. It won't be possible to be born and then have it fixed. And for some of those, it will be probably easier just to make sure that when you are selecting which of your your embryos to implant, that one is selected that doesn't have some kind of deadly genetic disorder.
Okay, now that's today. Now, you wrote an op-ed piece for the New York Times talking about the year 2045. So in the year 2045, what traits have been identified? They go far beyond looking at Tay-Sachs or Down syndrome or Huntington's. What kinds of traits are possible to isolate in the year 2045? And is it possible to modify our genome rather than simply discarding the embryos that have the wrong genetic makeup?
So let me take a step back to answer your question. So between now and 2045, we're going to shift our healthcare system from our current system of generalized healthcare to precision healthcare. You'll be treated based on your own individual biology when you're getting drugs or whatever. And the way that we're going to know who you are and how to treat you is that you'll have a lot of your relevant information as part of your electronic health records, most significantly your sequence genome. So we will all have our whole genomes sequenced, and the cost of genome sequencing is going toward nothing. And then when we have millions and then billions of people who've been sequenced and we compare what their genes say, their genotypic information, with how those genes are expressed, their phenotypic information, we're going to know more and more, not just about the simple genetics that we just discussed, but about very complex, genetically complex diseases, disorders, and traits. So how is that going to show up in the fertility clinic? So you're going to get there, and first, if you have only 15 embryos, we're going to know a lot, not just about diseases, but about, is this kid have the potential to be great at abstract math, or a great physicist like you, Michio, or a great sprinter? But then we're going to be able to use stem cell technologies, so it's not just 15 eggs, that we're going to be able to take any adult cell, a skin graft is probably easiest. You induce those skin cells into stem cells into egg precursor cells into eggs. Now you have 10,000, 100,000, pick a number, eggs. You fertilize them with the male sperm, and now let's say that's 100,000. You have 100,000 options, and you have an automated process for extracting and sequencing cells from each of those. So when you have 100,000 options, think of what possibility. There's so much variation between possibilities, even for somebody who has 10 embryos. At 100,000, it's a lot more. And then on top of that, we'll be able to do what has already begun. There was the first case of this carried out by a very, in my view, unethical scientist in China, but to go in and make a relatively small and discrete number of gene edits. And so to answer your question, what are the traits that people will be selecting for? And people will certainly be selecting for optimal health. People will be selecting for longevity. And then beyond that, I mean, there are a lot of options that people will have. I think many people will want to select for higher genetic component of IQ, maybe for greater likelihood to have a more outgoing personality. And so these are big things, and we're touching at the core of what it means to be a human being, and this will raise some very, very deep and profound ethical questions that we're going to have to grapple with.
Now, some ethicists draw a line, and that line is between, on one hand, curing disease, and who could be against that? These diseases are ancient diseases that have afflicted humanity since the dawn of time. Who could be against eliminating those bad genes? However, now we're entering the area of enhancement, that is making us better people. And for example, take a look at sports. Already at Princeton, scientists have been able to isolate the Mighty Mouse gene and the Schwarzenegger gene, the gene that makes you muscle bound. And then the question is, would you pay good money to see a sports team that wins because it's been genetically enhanced? Is that going to be the future of sports? There's no competition. It's just whoever has the best geneticist will win that sports. Will people pay money to see a contest between two genetically enhanced sports teams, knowing ahead of time who's going to win because one team has a better geneticist? What are your thoughts?
So, two really great questions. First, most people, if you ask them the question that you asked, would say, yeah, I have a gut feeling that therapeutic applications of genetic technologies are good, and enhancements are either bad or I'm uncomfortable with them. And if we lived in a world where there was just a clear divide between where therapy ended and enhancement begun, that would be easy. But the fact of the matter is there is no clear boundary. There is a very big gray area between those two. Just to use a very, very simple example, if somebody is having a child and that child is going to be 2 feet tall, and they say, well, we can do an intervention so that kid will be 5 feet tall instead of 2 feet tall. I think most people would say, well, it's really hard to be 2 feet tall your whole life. All right, that seems like it's probably okay. And then you say, all right, what if it's 3 feet tall? And then people say, all right, well, maybe 3 feet is okay. It's going to be impossible to say, all right, here is where the line where therapy ends.
Author of an exciting new book. It's called Hacking Darwin, Genetic Engineering and the Future of Humanity. And it's coming. It's coming a lot faster than you realize. The ability to design our children. For the most part, tremendous benefits are going to flow from this, because we're going to be able to eliminate some of the thousands of genetic diseases that have haunted humanity ever since the dawn of time. Horrible genetic diseases. In fact, it's believed that one of the Salem witches, in that infamous Salem witch trial, it's believed that one of the witches, so-called witches, suffered from Huntington's syndrome, which causes you to flail uncontrollably, and people thought she was a witch, and they burned her as a consequence. Well, with us today, once again, is Jamie Messel. The book is called Hacking Darwin. Now, the Olympics Committee has already set up a subcommittee. In fact, we interviewed one of the people who's on that subcommittee to look at genetic enhancement, because there is the Mighty Mouse gene, the Schwarzenegger gene, that's already out there. And drug testing is rather easy to detect by looking at steroid residues in people's bodily fluids. But it's a lot harder when we started to go into the area of genetics and proteins that are created by this. So do you think that this is nothing but the first of a whole slew of different kinds of problems we may face, given the fact that we're now crossing the line between curing disease and enhancing ourselves?
Absolutely, because right now when we look at our athletes, we just assume that everybody is natural, quote unquote natural, because they were born to two parents. But when we're able to look under the hood, when we're able to sequence people, we will realize that there is tremendous genetic variation between us. And there is absolutely no way that anyone can win the 100-meter sprint in the Olympics unless you have the genetic predisposition that makes that possible. There may be many people within that range, but there's just no way it's not going to happen unless you have those genetics. And so when we're able to look at those genetics, we will realize that there are some people who just have a genetic advantage over others. And we saw that in the 800-meter race with this South African runner, Castor. And so once we know this, everybody is critical of someone like Lance Armstrong, who did the blood doping to get so his red blood cells carried more oxygen. But what if we had somebody who we knew was just born with the genetic ability to already do what Lance Armstrong was cheating to achieve? How are we going to think about that? And will it be unfair for people who aren't just born with certain genetic benefits to compete against people who are? It's going to be very difficult to try to figure out what's fair and not fair, and especially as will happen in the coming decades, and certainly centuries, but decades, we are all going to be changing, and we're going to be changing as a result of embryo selection, but in sooner rather than later as a result of gene editing.
And let me ask you about the SMART gene, that is a gene for IQ. Recent studies show that there are perhaps hundreds of genes that influence intelligence in one way or another. There's just not one SMART gene. But with us today is Jamie Messel, author of an exciting book called Hacking Darwin. What happens if somebody says that they have found a gene for intelligence? There's going to be a stampede. Every parent will be under the gun. There'll be tremendous pressure for parents to enhance their children once the rumor gets out there that their competitors have been enhanced, even though scientists believe that perhaps hundreds of genes influence intelligence. So we have never been able to control the heroin market. However, what happens when genes are nothing but information after all, just digital code. What happens when bootleg genes become available on the internet? How are we going to regulate bootleg genes when we cannot even monitor drugs? What are your thoughts?
Yeah, so it's a lot of great questions. First, let me start with the issue of parents. So parents are crazy. Parents will do what it takes to give their kids competitive advantages. I spend a lot of time in Korea, and in Korea I have a friend. He has 11 tutors coming to the house every week to tutor his 12-year-old daughter. In Korea, they have a national law closing the cram schools every night at 10 p.m. because People are sending their 7 and 8-year-old kids to go study past work, to study past midnight, to prepare for exams they were going to be taking a decade in the future. And so parents are going to be aggressive when they believe they can get benefits for their kids. In the old days, we used to think that there was like a gene for a trait, like a gene for height, a gene for intelligence. But now we recognize, as you said, that there are hundreds, probably thousands of genes that say something about intelligence. And so there's a word that many people, two words that many people haven't heard of that's going to be really important in where we're heading. It's called polygenic scoring. And what that means is that we are going to use big data analytics for these big data sets of billions of people who had their genome sequenced, and we have their information from their electronic health and life records. And so then we're going to recognize very complex patterns of genes that create a higher likelihood of higher intelligence. And so when those tools are applied to pre-implanted embryos that have been sequenced, then where people are going to be able to make pretty informed guesses, but increasingly informed guesses about which of their embryos is likely to have a higher genetic component of IQ. And for those people who want that, those are the ones that they are going to implant. Could there be individual mutations, like a single gene mutation, that could confer some kind of additional benefit? It's possible. But I think the real killer application is going to be in the embryo selection, and parents are going to want it.
Now, also, it's gradually becoming possible to use genetics to determine a person's physical, facial characteristics. The police department's already looking at this technology. But what happens when people want to get access to movie stars' genome? Every time they go to the barbershop, some of their DNA may be left over on the floor of the barbershop, and some people may want to get access to those hair clippings, sequence it, and sell the genes of movie stars for profit, because people may want to genetically enhance themselves to look like their favorite movie stars. Already we have women who undergo a battery of plastic surgeries to look like Barbie dolls. Already we have lookalikes. So what happens when genetic lookalikes become possible? Privacy is in danger. So in other words, can you own your own genome, or can someone steal it and market it and sell it and claim that you could be the next Brad Pitt?
Well, you are the next Brad Pitt, so we'll leave that one aside. You're the current Brad Pitt, actually. But what I will say is people have this idea.
And we're talking about now the future. Not today, when we really cannot enhance our genome yet. We can barely identify the misspellings in our genome responsible for certain illnesses. But in the future, some people may declare that they've isolated the smart gene, the height gene, genes that affect even physical appearance. And then who owns the genome? Can you copyright your own genome? What happens if somebody tries to steal your genome by getting you to lick a stamp? They take your DNA off the stamp or off your hair clippings, and they market it, and they make money off your genetics. What happens when that happens? So, Jamie, what are your thoughts about whether or not this technology can get out of hand? Because we already today have people who want to look like movie stars and modify their bodies to look like Barbie.
Yeah, so it certainly can happen, and that's the question that we need to be debating now, is that we know that these technologies have the potential to help us in really fantastic, great ways that everybody will want. But like with all technologies, there is a real possibility of danger. So we need to make sure that we are creating norms and regulations that increase the chances that the good stuff will be optimized and the bad stuff will be minimized. So you talked about getting hair clippings from a movie star. And what I was saying before is people have this sense that we're going to kind of build all our children like at the Build-A-Bear showroom in the local mall. But it's actually going to be a lot more complicated because, as you and your listeners know, biology is extremely complicated. And so what I do think, though, is that once people identify traits that they want that are genetic traits, they're going to be able to select for those traits in their pre-implanted embryos. And if you have 100,000 embryos that you are choosing from, and you value height, or you value symmetrical appearance, or high genetic component of IQ, whatever those things are, you're going to be able to select for them if you want to, and if you're in a jurisdiction where it's legal. And but there are huge privacy issues, and it feels right to everyone, and it is right that people should own their own genetic information. No one should be able to steal your genetic information and use it or profit from it. But at the same time, we are going to need to recognize that the way we are going to be able to use these technologies is if we can build these very massive data sets of genetic and life information, because that's how we are going to crack the code of genomics and our own systems biology more generally. And so we're going to have to find a balance between wanting to have genetic privacy, but not so much genetic privacy that it limits our ability as a collective to benefit from the big data, applying big data analytics to these big genetic and life data sets.
Well, let me ask you a question then. Some people think that one day billions of humans will have their genomes available for research, including the genomes of old people and the genomes of young people, and we'll look at them by artificial intelligence, scan these genes using artificial intelligence, and isolate where aging takes place, and then be able to fix it using CRISPR technology. And some people think that the fountain of youth may actually be found by artificial intelligence, scanning billions of genomes, looking for patterns that indicate premature aging or aging in the genome, and maybe the fountain of youth is inside our bodies. What are your thoughts?
Yes, I fully believe that. And right now, there are a lot of studies of these superagers, these people who live past 100. And it turns out that if you live past 100, your healthcare costs in the last year of your life are 30% the cost of somebody who dies in their 70s. And so we are increasingly going to understand what are the genetic patterns that help some people live longer, healthier lives. And so one thing we're going to be able to do is, once we've identified those genes, is say, well, what are those genes doing? Because as you mentioned earlier, Michio, genes instruct cells to make proteins. So maybe, and what we will be able to just introduce those proteins as if you had these kinds of genes. And certainly when we are selecting our embryos, having future children with a greater than otherwise chance of living a longer, healthier life will be something that will be important to some people. So I absolutely, there's no reason, the longest lived human ever lived 122 years, but there's no reason that I see that we aren't going to be able to live longer than that, and certainly extend average life and health span.
And let me ask you a hypothetical question. You're also a science fiction novelist. And in science fiction, there's a philosophy called transhumanism. In fact, there are some people who actually subscribe to it, and they think it's a good thing to modify the human race. What's wrong with becoming smarter, better looking, better people? What's wrong with enhancing ourselves? And one day we're going to go into outer space, and we're going to have to genetically modify ourselves to live on Mars and beyond. So what are your thoughts about the philosophy called transhumanism?
Well, I know the transhumanist movement very well. I know many of the people who are involved in it. And I think it's a very legitimate philosophy for them. But not everybody believes that. And I certainly believe we know that this planet isn't going to exist forever, and that we're going to have to live somewhere else for humans to survive.